Let's take a look at angles and arcs. And we'll get my tablet up running. Okay. Now, when we go forever to the right and forever to the left, this is called a line. When you just go in one direction like this, this is called a ray. Now when we take that ray and we make a copy of it, duplicate it, and then we rotate it up like that, this is an angle. Now oftentimes angle are represented by Greek letters. This would be represented by theta. If it opens, if this is this would be your initial side here, so that's your starting place, and this is your terminal side. If your angle's opening up counterclockwise, then it's going to be positive. If on the other hand, here's your initial side, if your graph's opening up clockwise, then your angle is going to be negative. Now if I start right here, this is my initial side. If I come straight up, forming a sharp corner here, this is 90 degrees. It's also called a right angle. If I start right here, that's my initial side, and I go over to here, this is 180 degrees, and that's called a straight angle. Now some other names of angles while we're right here. If I start there and I go up to here, 30, let's say 30 degrees. If your angle is between 0 and 90, not including 0 and 90, so somewhere between 0 and 90, then this is referred to as an acute angle. If, here's my initial side, let's say I'm coming over to right here, let's say this is 120 degrees, and I'll refer to this as theta, so theta is equal to 120 degrees. If theta is between 90 and 180, not including 90 and 80, this is referred to as an obtuse angle. Okay. If I start here, we said if we go straight up here, it's 90 degrees. Come straight over here, it's 180 degrees. If I come down to here, this would be 270 degrees. And if I start here, this is my initial side, and I go all the way around such that my terminal side falls on my initial side, so it goes all the way around, completely around. This is 360 degrees. That's also considered one revolution. So that's one revolution. Now, let's take a look at our first problem here. We're going to talk about radians here in a little bit. Okay. Find the number of degrees in an angle formed by rotating the terminal side counterclockwise through the indicated fraction of a revolution. And the first one is 1/2. So that's 1/2 of a revolution. Okay, so we're starting here, and all the way around, ending up where we started, is 1 revolution. So 1/2 of a revolution would be over to here. So that's half of a revolution, which we've already said is a straight angle, which is 180 degrees. Now how you can do that algebraically is we take our 1/2 times 360 degrees. 360 degrees is completely around, which is one revolution, so half of a revolution, you take half times 360, which gives us 180 degrees. Now that's a very easy formula to use if you got something that isn't nice like 1/2, like 3/4. 3/4 may not be so easy to see where it ends up at, but if I take 3/4 times 360 degrees, this is like 3/4 times 360 over 1. 4 and 360, these are both divisible by 4. 4 divided by 4 is 1. 360 divided by 4 is 90. 3 times 90 is 270 degrees. And that would be our answer. And the next one is 1/5. Well, again, if I take 1/5 times 360 degrees, I think that's 72 degrees. And 4/5. So I'll take 4/5 times 360 degrees. That gives me 72 times 4, 288 degrees. Then you could plug those in your calculator. For example, 1/5 times 360. Let me show that. This is on a TA384 calculator. As soon as it comes up. Okay. So I got 1/5. So do 1 divided by 5 times 360 degrees. And that gives us our 72. Now let me clear this away, and then we'll start a new page. Fortunately, when I start a new page, a lot of times my software crashes, so I just do an undo until everything's gone on the page. Okay, next problem. We got first one is 90 degrees. The instructions say find a fraction of a counterclockwise revolution that will form an angle with the indicated number of degrees. So they're giving you the degrees, and they're wanting you to ask you what part of a revolution is it. Okay, well if I start here, we said 90 degrees was straight up there, counterclockwise. Well, remember all the way around is one revolution. So if I were to do these down here, all the way around is one revolution, so I can see that when I split it up this way that it appears to be 1/4 of a revolution. So 1/4 of a revolution. Now that's kind of hard to work just by looking at it. I mean, 90 degrees isn't too bad, but some of them you can't see that easy. So the way you do it algebraically, number-wise, is you take your 90 and you divide it by 360. It's always dividing by 360, and that'll give you what fraction, what part of revolution that represents. Well, these zeros would cancel. 9 over 36, and top and bottom both divisible by 9, so that gives me 1/4. Okay. Now 20. I'm not going to do it graphically, but you take your 20, you put it over 360. Zeros cancel. 2 and 36 both divisible by 2, so that gives us 1/18. And that'd be our answer. You can use your calculator to simplify the fractions if you want. So 20 divided by 360 inner. Now when we plug in 20 divided by 360, we get a decimal. To go from decimal to fraction on your calculator, you do math, inner. And we get 1/18th, which is our answer. And our last one, 60 degrees. Again, you'll take the 60 and you'll put it over 360. Zeros cancel, and I got 6 over 36, and which are both divided by 6. So that gives us 1/6. And that's our answer. So 60 degrees is equal to 1/6 of a revolution. Now these next problems ask us to identify what type of angle it is. So we got 110 degrees. We got 180 degrees, 25 degrees, and 90 degrees. And it says identify the following angles as acute, right, obtuse, or straight. Now, acute. Acute is when your angle is less than 90 and it's not negative. So it's actually between 0 and 90, not including 0 and 90. So this 25 degrees is going to be my acute. Now your angle that's exactly equal to 90 degrees, that's your right angle. Your angle that's exactly equal to 180 is your straight angle. And then your angle that's between 90 and 180, not including 90 and 180, is your obtuse. So the 110 degrees would be your obtuse. So just some basic definitions there. Now this next problem introduces a further breakdown. And we'll talk about it more here. We got 83 degrees and 35 with a single quote, and 20. Double quote. The instructions say change decimal degrees accurate to 3 decimal places. Now you have degrees, and remember what degrees are. Start here, straight up to here is 90 degrees. Over to here is 180 degrees. Over here is 270 degrees. So if I tried to graph 1 degree, I don't know, it'd probably be like right there where it's almost inseparable from that. So that's 1 degree. Well, why would we need a further breakdown than that? I can barely draw one degree. Well, when you got computer systems, surveying equipment, so forth, then you have a need to look at it in more detail. And this mark right here, this single quote, that refers to minutes. And there's 60 minutes in 1 degree. Now this double quote here, that's seconds. And there's 60 seconds, and you probably guess this, 60 seconds in 1 minute. That one's easy, the easy one. This one may not be so easy to remember. And so we want to convert this. Now first I'll show it by hand, then I'll show it on the calculator. We got 83 degrees plus 35 minutes plus 20 seconds. That's what's implied in between each one of these, is there's an implied plus. Now I want to convert all of these to degrees. So I want to figure out how to convert minutes to degrees. I could use something called dimensional analysis. And dimensional analysis works this way. We take what we're converting from, which is a 35, and we always put it over 1. So you always create a fraction by putting it over 1. Times. Now whatever unit of measure is right here, which in this case is minutes, is what goes down here. So again, whatever's up here goes down here. And we're trying to find some kind of connection between minutes and degrees. Well, up here we said 60 minutes is equal to 1 degree. So then these minute marks would cancel here, and would have 35 over 60 degrees. So this becomes 83 degrees plus 35 over 60 degrees, and that's now in degrees. Now seconds. Okay, we're going to use dimensional analysis again. Here's 20 seconds, and I'll put over 1. If seconds is up here, then seconds will be down here. And I know 60 seconds is in 1 minute, so I can do that. 60 seconds is in 1 minute. Oops. There we go. Now looking ahead, I notice that this is going to cancel with this because one's on top, one's on the bottom. And that would convert it to minutes, but that's not what we want. We want to convert it to degrees. So if this is minutes here, then minutes has to go down here. That's always how dimensional analysis works. Whatever unit measure is here always goes there. And we've already said that there's 60 minutes in 1 degree. So then looking ahead, this minutes mark here, we cancel this minute mark. 20 times 1 times 1 is 20. 1 times 60 is 3,600. And we're left with a degree. So it looks like to change seconds to degrees, we're going to divide by 3,600. Well, now we're going to plug that into our calculator. So I got 83 plus 35 divided by 60 plus 20 divided by 3,600. Enter. And we got 83 point, and they're saying accurate to 3 decimal places. So we got 83.589. I round up. 3 decimal places, here's an 8, and the next one's a 5 or greater, so we round up, and that becomes a 9. And that would be degrees. And that's our answer. Okay, now maybe a little bit easier way to do that than do it completely by hand is come over to our calculator, and we want to press our mode button, which is right here, and we want to make sure that we're in the right units here. We're working with degrees, so I want this to be in degrees. If yours isn't in degrees, you down arrow to that line, right arrow, put your flashing cursor on the degrees, and you press enter 1 time. Then to exit out of anything in your calculator, you do second mode. Okay, so now I want to put in 83 degrees. So I'm going to do 83. Now we need to go into the angle menu. So I'll do second apps to go into the angle. And you see our first option is degrees. So I'll press enter on that. And then I want 35 minutes. So I'll do 35. I'm going to do a second apps again to go in my angle menu. And I want to down arrow to 2. And I want to choose this one. That's my minutes. Then I want 20 seconds. So do 20. And unfortunately, seconds isn't underneath the apps menu. Or under the angle menu. I'm not sure why. But I'm looking for it here. There it is. It's above the plus. So if I do alpha plus, it'll put my double quote on there for me. And then if I press enter, you see we get our 83.589. So that's how you convert it on the calculator. Okay, number 5. Change the degree minute second form. So we got 43.453 degrees. I'm going to show this completely on a calculator here in a second. But we want to change it to degree minute seconds. So we're going to split this up. We'll split the whole part separate from the decimal part. Now to go from degrees to minutes, I'm going to do a dimensional analysis over here, so we'll take a look at it. We got 0.453 degrees. Now throw it over 1. You always create a fraction by throwing it over 1. Times, and we have a fraction here, and if degrees is up here, then we'll have degrees down here. And we've already said that there's 60 minutes in 1 degree, so we'll have 60 minutes over 1 degree. So then I'd cancel these degree marks here, and it appears like we're going to multiply 0.453 times 60, and that'll change it to minutes. So that's where our goal is here. We want to change this to minutes. So we're going to take 43 degrees plus 0.453 times 60, and that'll change it to minutes. So we got 43 degrees plus 0.453 times 60. Enter. We get 27.18 minutes. Okay, well, we want seconds also, so we got 43 degrees. I'm going to split this up just like we did before. So this will be 27 minutes plus 0.18 minutes. There we go, minutes. Now this we want to change to seconds. And if I don't know what to do, if I come over here inside and try dimensional analysis, then it'll be obvious. Again, dimensional analysis, you take what you're converting from, you put it over 1. You create a fraction. Now the second fraction here, we got minutes up here, so it'll be minutes down here. And we got some kind of connection between minutes and seconds. We know that there's 60 seconds in 1 minute. Now the minutes would cancel here, and I see to convert the seconds, it looks like we multiply by 60. So we'll take 0.18 times 60, and that'll convert it to seconds. Okay, so we got 43 degrees plus 27 minutes plus 0.18 times 60 seconds. So 43 degrees plus 27 minutes plus 0.18 times 60. Enter, and we get 10.8 seconds. And usually you write it without the pluses there, so this would be 43 degrees, 27 minutes, and 10.8 seconds. Oftentimes when you got decimals in these, they'll have you just round like normal, but barring any other instruction, that would be your answer. Okay, now let's take a look at how to do it on the calculator. This is in degrees, so we want to make sure our mode's correct, and ours is still degrees. If I press mode, we're going to see degree highlighted. Do a second mode exit out. I'll press clear to clear out both of these. And we got 43.453. And I can't remember if you need to put degrees here. Let's try it. I'm going to do second apps and choose angle, and we want to choose number 4. Degree, minute, second. That little triangle there means we're going to convert it to degrees, minutes, and seconds. So I do enter on that, enter again, and we get 43 degrees, 27 minutes, and 10.8 seconds. Same answer we came up with by hand. Let me clean that page off, and then we'll do the next problem. So is it? There it goes. Okay. Now this one is giving us 2 angles. This symbol here is alpha, so it's telling us alpha is 37 degrees, 15 minutes, and 23 seconds. And they're telling us this B with an extra line, that's beta, is equal to 37.237 degrees. And it says write alpha is less than beta, alpha is equal to beta, or alpha is greater than beta, as appropriate. So we need to convert these so they're in the same measurement. This is in degrees, minutes, seconds form, and this is just in our decimal form. Well, I'm going to convert this degrees, minutes, seconds to decimals. Now if I was doing it by hand, this would be 37 degrees plus 15 minutes plus 23 seconds. And we saw this in an earlier problem. To convert from minutes to degrees, you divide by 60. So this would be 15 divided by 60. And to convert from seconds to degrees, you divide by 3600. So this would be 23 divided by 3600. So we got 37 plus 15 over 60 plus 23 over 3600. And enter. And we get 37.256, rounded 3 decimal places, degrees. Now this is alpha, and if you compare that against beta, it looks like that alpha is greater than beta, and that would be your answer. Okay, these next problems, we're going to take a look at comparing degrees and radians. So on this one, we got 120 degrees. Now you said to draw it. Remember, this is our initial side, that's our starting side. And clear over here would be 180 degrees. So coming up right here would be 90 degrees. This is 180. So 120 would fall over here. Now between 90 and 180 there's 90 degrees there. So if I split this into thirds, as well as I can do it by hand, 90 plus 30 is 120 degrees, plus another 30 is 150 degrees, plus another 30 is 180 degrees. So 120 degrees would be right here, and that would be our angle. Okay, now let's talk about radian measure a little bit. We said start here, we come up to here. We said that's 90 degrees. In terms of radians, that would be, now radians all the way around is 2 pi. Halfway over is pi, and then half or a quarter of the way, all the way around the circle, completely around, is pi over 2. So 90 degrees is pi over 2. Now if I start here, and like I said, I go completely over to there, we've already said that's 180 degrees, or in terms of radians, that's pi. Now it's very easy to tell the difference between degrees and radians. If you have a little degree mark here, or if you have the minutes or seconds, then it's degrees. If you don't have it, then it's referring to radians. So if you see a problem that says 76, for example, and that's referring to our angle, well, that'd be radian, because there's no degree mark here. Okay. Right here, and I go clear over to there. We have already said that's 270 degrees. Now up here is pi over 2, then down to here is pi, so you add another pi over 2. This is going to be 3 pi over 2 in terms of radians. And then if I start over here, and I go all the way around back to my starting place, we said that was going to be 360 degrees, or in terms of radians, it'll be 2 pi. Now the important one we're going to use for problems is this right here. And we'll come back to that. That's when we're doing conversions. Okay, so let's take a look at this one here. We've got 2 pi over 3. Well, here's our starting place. And clear over here would be pi. So this, if I were to write the fraction separate, this says 2/3 pi. So we're going to go 2/3 of the way over. So if I sketch this, trying to split this into thirds, as good as I can do it, there's this angle here, should be the same as this, should be the same as this. They all open up the same measurement. Now 2/3 pi, over to here is 1/3 pi, so 2/3 pi would be right here, more or less. It's 2/3 of the way over to this pi that's over here. Okay, 19 pi over 4. Well, let's talk about quarters first off. start here, and we said that if we come up to here it's 90 degrees, come over here it's 180 degrees, and come down here it's 270 degrees. Well, if this is 90 degrees, and this is 180, and then 270, and then all the way back to 360 or 0, then if we put that in terms of radians, this will be 0. Up to here would be pi over 2. Over to here would be pi. Down to here would be 3 pi over 2. Now halfway in between 0 and pi over 2 would be pi over 4. This would be 3 pi over 4. Now I'm keep adding pi over 4 over and over. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and this would be back to 8 pi over 4, which is simply 2 pi. Okay, so to graph 19 pi over 4, it's probably easier to split the fraction away from the pi. So we got 19/4 pi, which if I change this to a mixed number would be 4 3/4 pi. So I'm starting here. That's my initial side. Now I'm coming over to here. That's 1 pi. Over to here is 2 pi, 3 pi, 4 pi. So right to here would be 4 pi. Now I want to still go another 3/4 pi. All the way over here would be another pi, so 3/4 of the way would be that right there. And that would be our 19 pi over 4. Again, mixed numbers is probably easier to work with on that. Let me start a new page. Okay, so now let's go over to our next problem. 30 degrees. Now I like to show this by example. So we got 30 degrees, and let me sketch this, even though they're not asking us to sketch it. Well, coming straight up to here would be 90 degrees. So 30 would be here somewhere, and I can split this into thirds. So I go here, so up to here would be 30 degrees, up to here would be 60 degrees, and then 90. I keep adding 30 over and over. So 30 degrees is right here. Remember, this is 180 degrees, this is 270, and then back to, this is 0 degrees or 360. So this is the angle we're starting with. And they say, find the degree measures of the two nearest angles, one positive and one negative, that are coterminal with a given angle. So let's talk about what a coterminal is. Remember, this was our initial side, and then the ending side is our terminal side. So to get one that's coterminal, what you can do is where this one left off, what you're going to do is you're going to add 360 degrees. Because if I add 360, I go all the way around the circle and we're back where we started. So this is still the same terminal side then. Or you could start here and you could go the other direction all the way around the circle. So to get angles that are coterminal, you can add or subtract 360 degrees, or you can add or subtract 2 pi over and over. So on this one, we're going to take our 30 degrees and we'll add 360, and that gives us 390 degrees. So 390 degrees is coterminal with 30. Or we could subtract. 30 degrees minus 360 degrees is negative 330 degrees. And those would be our two answers. Okay, let's take a look at this one. We got pi over 6. Now I'm not going to draw the picture on this, but it says find the radian measures of the two nearest angles, one positive, one negative, that are coterminal with the given angle. Just like when we were working with degrees where we could add or subtract 360, when you're working with radians, you can add or subtract 2 pi. So we got pi over 6 plus 2 pi, and we'll have pi over 6 minus 2 pi. Now remember these from basic math. We got 3.5, which was the same as 3 plus 1/2. This is a mixed number. And we had our mixed number rule. Mixed number rule said we took the number to the side, we multiply it times our denominator. So we take 3 times 2, and then we'll add our numerator. And then your denominator stayed as is. Okay, so I took the number to the side, I multiplied it times my denominator, and I added my numerator. And then the denominator stayed as is. 3 times 2 is 6, plus 1 is 7, so that would give us 7/2. You can do the same thing when you have this, because remember, the pi there's an invisible 1 in front of it, so that's like 1/6 plus 2. So I take the number to the side, I multiply times my denominator, so 2 times 6, and I'll add a number on top, which is the invisible 1, the numerator. And then my denominator stays the same, so it stays 6 pi. 2 times 6 is 12, plus 1 is 13, so that gives us 13 pi over 6. This one, you can do the same thing. So we'll take the number to the side, -2, we multiply it times our denominator. And then we'll add the number up on top, our numerator, which remember is invisible 1. And then our denominator stays as is. So negative, oh, and there's a pi there. -2 times 6 is -12, plus 1 is -11. So we got -11/6, or -11 pi 6, sorry. Let me see if that's right. -2 times 6 is -12, plus 1 is -11, yeah. So those would be our answers. Okay. Now this next problem here. It says convert each angle in degrees to radians, express your answer as a multiple of pi. So let me scroll down here. We got 85 degrees. Now dimensional analysis makes it real easy. Dimensional analysis says you always create a fraction, so put it over 1. Times. And if degrees is up here, then degrees has to be down here. That's the way it always works. Whatever unit measure is right here, always goes down here. And we're trying to find some kind of connection between degrees and radians. Well, we said 180 degrees is equal to pi radians. And I'll put an RAD there just to really emphasize the radians. And remember where we got that at. If I started here and went over to here, that came out to our 180 degrees. And we also said that was equal to pi in terms of radians. Now these degree marks will cancel. And we got 85 pi over 1 times 80 is 180. Top and bottom are both divisible by 5. Let's see, 1 there, 17 pi over 36. You can definitely use your calculator to simplify the number portion. It won't handle pi, but if I did 85 over 180 on my calculator, 85 divided by 180, and press enter, and then do math, enter, you see we get our 17 over 36. So if you're big into formulas, I'm not big into formulas if I can use dimensional analysis, because dimensional analysis guides you on exactly what to do. But to go from degrees to radians, you multiply by pi over 180 degrees. Now the radians just drops away. You never really need to do that. If it doesn't say degrees, it's by default radians. Okay, number 13. We got negative 120 degrees. Same thing. I'll put over 1. You always create a fraction. Now if degrees is up here, then degrees has to be down here. So this will be 180 degrees and pi radians up on top. Well, that gives us the degree symbols cancel. So we got negative 120 pi over 180. They're both divisible by 10, so that gives us negative 12 pi over 18. And they're both divisible by 6, so that gives us negative 2 pi over 3. And that would be our answer. Now let me come up here and I'm going to clear off that page. Wish there was a fast way to do that, but there isn't. There we go. And let's take a look at our next problem. This is going the other direction. We want to convert from radians to degrees. So we got pi over 3. Now, if there were a unit of measure here to be listed, it'd be radians, because remember we're dealing with angle and there's no degree mark. Well, dimensional analysis says you got radians here, you'll have radians down here. And we're trying to convert it to degrees. Well, we said earlier that 180 degrees is equal to pi radians. So then we can do some canceling. Of course, those radians are gone anyway, but the pi's would cancel. And we end up with 180 over 3 degrees. And 180 divided by 3 gives us 60 degrees. And that would be our answer. Okay. Now here we got 51 degrees. And notice the instructions. Convert each angle in degrees to radians. Express your answer in decimal form rounded to 2 decimal places. The implication here is that we're going to use a calculator to do the conversion. Now we're trying to convert from degrees to radians. So your first thing on your calculator is you want to press your mode button and you want to put your calculator in radians. So I'm going to down arrow to radians and I'll press enter one time. So after I got radians selected, then I'm going to exit out, so I'll do second mode. And we want to put in 51 degrees. Now you just don't want to put in 51, you actually have to put the degree mark. So we'll go into our angle menu. So I'll do second apps. I'll choose the first one, because that's the degree. And then I press enter. And that'll convert it to radians. Rounded to 2 decimal places. So that'd be 0.89. Now I'll put an RAD there just to really emphasize it, but again, no unit of measure is necessary, but that's my radians. Number 16. We got square root of 3. Now as you look at this, it's wanting us to convert each angle in radians to degrees. It tells us that, but if I knew this was an angle measure, the fact that it doesn't have degrees automatically means that this is radians. Now we have to look at what we're converting it to. We're converting it to degrees. So I'm going to change my mode to degrees. So I press my mode button. I'm going to down arrow and right arrow and put my flashing cursor on degree and then press enter one time. Then I'll exit out. And we got square root of 3. So I'll do second x squared for the square root. I'll put 3 in. And I need to put a closing parentheses on mine. If you got one of the newer TI-84s, you do not need to put a closing parentheses. You need to press your right arrow key to get it out of the square root symbol. Now I want to go back into my angle menu. So I do second apps. And I want to choose number 3. This will tell it radians. So we're telling it square root of 3 radians. And since we changed our mode to degrees, when I press enter, it's going to give us this. And rounded to 2 decimal places would be 99.24. So 99.24 degrees. And that's our answer. Now these last ones revolve around area, well, we're dealing with circles. And specifically, we're taking a look at a little piece of the circle. And this distance here, this is the arc length, this is S. R is our radius, going from the center out to the outer edge. A represents the area of this little piece right here. And the angle, this right here, is usually represented by theta. Okay, so for these next problems, we got r is equal to 3 feet, and theta is equal to 4 radians, and I'll just put a 4 there. Well, let me go ahead and put the radians to emphasize it. And it wants us to find the missing quantity, and it tells us to use the formula S is equal to r theta. That's the formula that will give us the arc length. Now, in order to use this formula, theta has to be in radian measure. You can't use it. You can't use this formula if theta is in degrees. Well, r will be 3 feet, and we already said that theta is equal to 4 radians, which is in radians. So put 4 there. So then S is going to equal 3 times 4 is 12 feet, and that would be our arc length. Now compare that to this problem. So we got 18, r is equal to 7 meters, and theta is equal to 60 degrees. We said we can't use that formula unless degrees is in radians. So I need to convert 60 degrees. Now remember, we put it over 1. You always create a fraction like that. And then if degrees is up here, then degrees has to be down here. And we said that 180 degrees is equal to pi radians. I'll put the RAD there again just to really emphasize it. Now the degree marks would cancel. So we'd have 60 pi over 180 radians. And I'll drop the radians in the next step. 60 over 180 gives us 1/3. So this becomes pi over 3, and it's in radians. So now we can plug it into our formula. We got S is equal to r theta, and r we said was 7 meters, and theta we said was pi over 3. Now it says round to 3 decimal places, so let's go multiply that together and see what we get. 7 times pi, second caret, divide by 3, and press enter. So we get 7.330 meters. The 0 just dropped away anyway, so it's just 7.33 meters. And that's our answer. Okay, number 19. This is a different formula we're working with. We're trying to find something in here. So we got A is equal to 1/2 r squared theta. This is based upon the same picture as I showed you up above. Here they're telling us that theta is equal to 1/5. They say radians, but again, we know if we don't put the degree mark, it's by default radians. And A is 4 square centimeters. So A is 4 centimeters squared. Well, it looks like the missing variable is r. So let's plug these in and solve for r. So I'll put 4 centimeters squared in for the A. 1/2 times r squared times theta, which we said was 1/5. 1/2 times 1/5 is 1/10. R squared. Multiply both sides by 10. Those 10's going to cancel. 10 times 4 is 40 centimeters squared is equal to r squared. Now, square root property from college algebra. Remember, if you got something squared equal to something else, you drop the squared and you put a square root around the other side. Now, specifically, we put a plus or minus around the other side. But since we're dealing with radius, radius cannot be a negative distance. So we don't need to put the plus or minus on here. It's automatically going to be positive. Now, if I were to simplify this, 40 is 2 times 2 times 2 times 5. If I did tree breakdown, that's how I get that. Somebody asked me in another class how I got that. 40 is 2 times 20. 2's prime size circlet. 20 is 2 times 10. 2's prime size circlet, and 10 is 2 times 5, and 2's prime size circlet, and 5's prime size circlet. Now centimeters squared, we're going to treat that as a variable. So that's centimeter squared means centimeters times centimeters. Now remember with square roots, we're looking for pairs of something. Here's a pair of 2's, so they're going to come out as a single 2. And here's a pair of centimeters, they're going to come out as a single centimeter. So we'll have 2 centimeters come out, and we're left with 2 times 5 inside, which is 10, equals r. So we got 2 square root of 10 centimeters is equal to r. Now they probably want us to round it to 3 decimal places again. So let's plug that in to our calculator. 2, then second x squared for the square root. Put in 10, press enter. And we get 6.325 centimeters. And that would be our answer. Now let me clean out the page. Wish there was a fast way to do that. That didn't cause my tablet to crash. There we go. Okay, so let's look at our next problem. This is giving us the picture. And we got a is equal to 1/2 r squared theta, and s is equal to r theta. And it says find the length s, so find the arc length, and the area a. Round answer is 3 decimal places. Well, it tells us that theta is equal to 60 degrees, and r is equal to 10 centimeters. Well, we've already said that we need to have the angle in radians in order to use these formulas. So I'm going to put this over 1. Remember how it works. Degrees is up here, so degrees has to be down here. So we'll have 180 degrees is equal to pi radians. The degree marks would cancel, and I'd have 60 pi over 180, or pi over 3. So then we'll have 1/2 times r squared. R was 10 centimeters, so I got 10 centimeters squared, times theta, which is pi over 3. Now, if everything inside of your parentheses is multiplication or division, you raise it into a power, you can take everything to that power. And remember, we want to treat units of measure like they were a variable. So this is like 10 times a variable. So we're going to take the 10 to the second power and the centimeters to the second power. So we're going to have 1/2 times 10 squared times centimeter squared times pi over 3. So we got 1/2 times 10 squared, which is 100, times centimeters squared times pi over 3. 1/2 of 100 is 50, so I got 50 pi over 3 centimeters squared. Now if I plug that into my calculator, 50 pi, so 50 and then second caret divided by 3, and then press enter, and we get 52.359, but then I round up and that becomes 36 centimeters squared. And this one, r, which was 10 centimeters, times theta, which we said was pi over 3. So that gives us 10 pi over 3 centimeters, which if I plug that in, 10 and then second caret for the pi divided by 3, and press enter. And we get 10.3 decimal places, 472, rounding up, centimeters. And those will be our 2 answers for that problem. Okay, number 21, the last problem. It says a wheel is rotating at 120 revolutions per minute. Find the angular speed in radians per second. So where we're headed is we want radians per second. Now they give us 120 revolutions per minute. So 120, and I'll put REV for revolutions, over minute. And when they say per minute, they're saying that we're looking at 1 minute. Okay, so that's what we're starting out with. We want to end up with this. Well, first off, dimensional analysis. If this is on top, then it has to be on the bottom of my second fraction. And I've already said that one revolution is all the way around the circle, is equal to 2 pi radians. So I'll put 2 pi radians there. Now looking ahead, revolutions cancels with this revolutions because one's on top, one's on the bottom, they're the same. And what I'm left with currently is radians per minute. That's not what I want. I want radians per second. Well, if minutes is down here on the bottom, then if we're going to do any kind of conversion involving that, we have to put minutes up here. Because if this is on the bottom, this has to be on top. And I'm hoping I can find some kind of connection between minutes and seconds, which we know there's 60 seconds in 1 minute. So then, canceling this minute with this minute, I'm going to end up with 120 times 2 pi times 1, which gives me 240 pi. And here we got 1 times 60, which is 60. And this is in radians per second, which gives us 4 pi radians per second. And doesn't tell what form, but if I do 4 pi on my calculator, 4 times pi, I'll take it 3 decimal places. We get 12.566 radians per second. And that would be our answer. And that's the end of that lecture.